Hello everyone. In this video I'm going to be diagnosing the integrated wheel ends on a 2020 F150. This was brought down to me. Someone has already replaced the left front wheel bearing. They thought the wheel bearing was bad. I'll show you what when these have a partial engagement, what these integrated wheel ends or IWEs make, and it sounds similar to a bad wheel bearing, but this one's got a four-wheel drive issue. It's the IWEs are staying partially engaged, and so we're going to go through this system and show you how to check it. Let me show you the strategy on this. So Ford says on the transfer case control module has two startup strategies that affect the IWE operation. So when the ambient temperature is below 32 degrees, the IWEs engage after initial key cycle and a driven gear is selected. The hubs stay engaged regardless of the 4x4 mode change for approximately 2 miles. So the second strategy is when the ambient temperature is above 32 degrees, the IWEs engage after the initial key cycle and a driven gear is selected. The hubs stay engaged regardless of 4x4 mode change for approximately half a mile. So if it's below 32 degrees, they're going to stay engaged even if it's in two-wheel drive for 2 miles. And same thing, even if it's in two-wheel drive but it's above 32 degrees, the IWEs are going to stay engaged for half of a mile. So the components in this system are a vacuum supply line. Some of these engines will have a vacuum pump, some won't. A one-way check valve, which is critical. This little guy, this little plastic check valve is really critical. The vacuum supply line that goes to the IWE solenoid and to the vacuum reservoir. And then the line going out, this output line goes down. I'm wiggling that, it goes down to your integrated wheel end, which is right here. I think you can see that. And there's the vacuum line that goes to it. So the computer, it has constant power on this gray with red tracer, and it looks like a brown wire on this other side. So the gray with red has power all the time, and this brown wire, the computer will ground this solenoid to open it up. So that's critical. So if any component on this system fails, this check valve, the vacuum reservoir, or this IWE solenoid, or the line going down, or an IWE, if it fails, it will automatically default to engagement, or the IWEs will engage anytime there's not a vacuum. So if you ask me, they did this backwards. They should have done it the other way, to where it's always got vacuum, and when the computer grounds or open this, it will release the vacuum when you put it in four-wheel drive. So if there's an issue, it will default, it will lock these IWEs in, which this one is. So sitting here on the rack, this IWE is engaged. Okay, for the testing on this, I'm just going to go ahead and start up the engine, let this run the entire time we're testing it. Typical clangy EcoBoost. They sound kind of rattly when they're cold. So the first thing we're going to do is we'll pull the vacuum line on this check valve. See if we have vacuum here. and we do. And we'll put a vacuum gauge on it. So we've got about 17 inches of vacuum. Now, when I shut this engine off, the vacuum should not drop more than 1/2 of 1 inch of mercury per minute. If it drops off really fast, you know this check valve is bad. Shut it off. Yeah, it instantly drops. So this check valve is bad. The next check we're going to do, we'll pull this line at the reservoir, put a vacuum pump on it, and let's pump this up. They want you to put 20 inches of vacuum on it, which is going to take a little while. My hand's going to get tired. That's good enough. And then you're going to look to see if it holds and holding nice and steady. So the reservoir's good. And we'll go ahead and plug this back in. You can hear vacuum on the supply side. We got vacuum there. Go ahead and plug in this supply line. We're going to plug in the output port. It's this top port on the solenoid. So the supply is the bottom, the output's the top. This output's what goes down to the IWEs. We're going to go ahead and put our vacuum gauge on that. So we know this solenoid is closed because we don't have any vacuum on it. So we know we have vacuum to the supply side, but nothing going down to those IWEs. And then you can use a scan tool. I don't have it hooked up. And we can go ahead and just power up the solenoid, but we'll just use my power probe. First of all, we'll check for power on this I think it's gray and red. Looks like gray and red. We got power there. We should have power through the other side. The solenoid's fine, which we do. So the computer's going to ground this side. Now if I ground this, we're going to have vacuum. Let's ground it. There we go. Let off, ground it. Okay, now we're going to get it all connected back in, and we'll leave the power probe on here. We'll ground this and supply vacuum down to these IWEs and make sure that they're disengaging. But I'm going to go ahead and put it in 4-wheel drive. Drive it on the rack. Let's put it in 4-wheel drive. 4x4 shift in progress. Okay, I've got it in 4-wheel drive. Let's see here, everything's turning. Both sides. We can disengage these IWEs by grounding it. So let's ground this. There, it's disengaged. You can see the left axle still turning. Now we'll take the ground off. There it engages. So if there's an issue with this system in 2-wheel drive, it's going to turn these IWEs on. Like I said, I think Ford did it backwards. They should have done it the other way around, but that's the way the system is designed. Now, the noise that these will make is if it has
partial vacuum. Usually when you're accelerating, the vacuum will drop. If vacuum goes down, if you got a bad check valve or a leak somewhere or a bad IWE, it will make a ratcheting noise. And let's see if we can get it to do it. Let's connect our vacuum pump in to the line going down to the IWEs. And what we'll do, so well, first off, let's see what vacuum it takes to disengage this. And I think it's only like 5 inches of vacuum. So we're going to do this right now. There's about 2. Oh, this one took almost 10. There we go. So there's the noise it'll make when it's about 5 inches of vacuum. Hear that rattling? So the axle's turning, but this IWE is partially engaged. You see it rattling on that. So let off a little bit more vacuum. Yeah, it looks like it needs almost 10 inches to disengage that. You can see our axle still turning. And we'll take the vacuum down. Yeah, partially engaging. Sounds awful. So that's how the system works. I think it's, I don't know. These things have a lot of problems. I think they could have done something different on this. But that's how these Fords work. This one also has a bad IWE on the other side. I'll show you. So we'll disengage this. Okay, this one's disengaged. Axle's turning. Holding vacuum. So this thing actually has 2 problems. Of course, they replaced this wheel bearing. They didn't know what they were doing. But if we look at this side, look at that one. Still turning. So this IWE is stuck in all the time. A lot of times they will just bleed off vacuum, and they will always stay engaged. This one holds vacuum. It won't disengage. Okay, let's go right at the IWE. We'll pull this vacuum line. I'll show you how to test these. There's a big port and a small port. You're going to go on the big one. So right now we're engaged, and we're going to put some vacuum on it. There's 16 inches. See the wheel bearing, the hub is disengaged. The axle's not turning. If I release the vacuum, there it's engaged. So let's check this other side. I know this side is staying engaged. It's bad, but we'll check it anyway. Okay, put the vacuum line on the larger fitting. So right now it's engaged. And there's 20 inches of vacuum. This thing's still engaged. So this one's got a bad IWE. A lot of times they just won't hold vacuum. But this one holds vacuum, just won't disengage. So something's messed up inside of it. It'll need a new IWE, and it's this right here. This piece of aluminum. It's got a seal in there and like a bladder. All right, there you have it, guys. That's how these IWE system works on these Fords. Now, this is completely separate than the transfer case. Now the transfer case has a motor and a clutch inside of it to engage, to make a connection from the front drive line to the back drive line. So when this is cold, or when it's below 32 degrees, the computer, the transfer case control module, will not ground the IWEs so it can stay engaged. You won't feel it because the transfer case will not be engaged from the front to the back, but the IWEs will be in, so that's to circulate the fluid and warm the fluid up. And then when it's above 32 degrees, it will have everything up here engaged and turning. So the front drive line, everything in the differential and the axles will be turning for the first half a mile. Now when it's in four-wheel drive, these will be connected through the clutch and the transfer case, so the front drive line, rear drive line, and the IWEs. So there you have it. Hope this video helps you out. Thanks for watching, and we'll see you in the next video.